Greetings, calculus students. This is Mr. Myron coming to you with a quick video about the linear approximation that was referred to in Q Theory Day 1 video. And so that's about a customer arriving between 0 and delta t. So we'll discuss this real fast and go through the proof of it. We start with the integral from 0 to delta t of lambda e to the negative lambda t dt. And so as we try to solve this, you need to evaluate that integral. And perhaps some u substitution would be nice to use here. Negative lambda t is the exponent of your exponential function. I'm going to let that be u, which makes du negative lambda dt. You don't have a negative lambda, so we're going to divide this to make it negative du equals lambda dt. And so by u substitution, what this tells us is that we now have an integral of negative e to the u du. And I like to change my limits of integration, and so if my lower limit of integration is 0, that means that when I change things into terms of u, that my new lower limit of integration is also 0, because you plug 0, which is your t variable, 0 in for t here, and so you get u equals 0. And then your upper limit of integration was delta t, so that goes in for t here, so your new upper limit of integration is negative lambda delta t. So this is much easier to integrate. You find the antiderivative of that, which is just obviously negative e to the u, and you evaluate that definite integral from 0 to negative lambda delta t. Evaluate your limits of integration. So you plug in your negative lambda delta t in for u, so you get negative e to the negative lambda delta t minus, what would you get when you plug in 0? So minus a negative e to the 0, which would just be plus 1. And that's the probability that the next arrival will occur between 0 and delta t. Now, in the video we talked about how we want to do some linear approximation with this as delta t goes towards 0, so on a very small interval. So we need to find your equation of the tangent line, which you students know and love your equation of the tangent line as the y minus y1 equals slope times x minus x1. So we need to convert this function into some sort of understanding of x's and y's and m's and stuff like that. So, this is our probability. So we're going to let that equal y. So y equals 1 minus e to the negative lambda delta t. That's your y value. y1 is what happens at your specific value, and you have m, which would be the derivative. So we need to find the derivative of this. Of course, we just integrated to get this, so by the fundamental theorem of calculus, you should end up with just what's inside the integral, or you could just derive this, and you'll find that dy dt equals positive lambda e to the negative lambda t. So you've got your derivative, you got your y equals. Now, again, the whole reason this equation tangent line is what we need is because we want delta t to go towards 0. So we need to know what our input is, and if our input, I'm going to let that be x, call that delta t. Again, I'm trying to create some notation here that you can use this formula. So x is going to be delta t, and y would be just whatever f of delta t is. And so there you have x and your y value. And now you need to know what x1 is and y1 is. So x1 would be what happens as delta t is going towards 0, so that's just 0. y1 is what you get as an output of 0. Of course, if you plug 0 into this, you get out 0. Or if you plug 0 in here, you're integrating from 0 to 0. So anyway, you end up with y1 equals 0. So with our equation, the tangent line, the y minus y1, this is what we end up with. We end up with f of delta t minus f of 0 equals your derivative, m, I'm going to come back to that, times delta t minus 0. So we need to figure out what m is, and what students sometimes make mistakes, they just put the derivative in there. But remember that this derivative has to be evaluated at your x value. So we need to evaluate dy dt at delta t equals 0, or as t goes towards 0. And so you plug 0 in here for t, this becomes 0, this all becomes 1, so that just equals lambda. So your derivative of this as delta t goes towards 0 is equal to just lambda, and so a lambda goes into this spot. And as we try to evaluate the f of delta t, then you have this f of 0, which we've already figured out is 0. So you have just f of delta t on the left side equals lambda times delta t minus 0, which is just delta t. And this is as delta t goes towards 0. And this is what video stated we were going to use for the probability that your next arrival occurs in delta t time units. So that all this work explains why we used lambda delta t in that spot. Thank you.